And we'll do one more question here from your application of vectors worksheet. This is question 16, obviously. On a day when the wind is blowing 70 kilometers an hour, west 40 degrees south, you wish to fly to a destination 830 kilometers east 60 degrees south in 1.5 hours. What heading and speed should you fly your plane? That's just a long way of saying what velocity should your plane have. This question is a little bit different. You're given a wind velocity and you're given a destination in terms of a displacement. So you've got to make those units the same. You can't do vector calculation with those different units. Because you're given the time, you can divide the displacement by time, and that gives you the average velocity that you need your plane to have. So that's kind of the first thing that I'm going to do here. So the average velocity that I need from this plane is my displacement divided by the time. So 830 kilometers. East 60 degrees towards the south divided by a time of 1.5. So the average velocity I need my plane to have to get to my destination is 553 kilometers an hour. Nice and fast. East 60 degrees south. So the direction of the displacement and the direction of the average velocity, of course, are the same. Here comes the tricky part. We need to incorporate the wind. So how fast should I fly this plane and in what direction, incorporating a wind of 70 so that I end up going, in the end, 553 and east 60 degrees south. It might be easier to picture if you kind of consider a short little diagram. Here's my little dot. You can kind of think of that as the plane if you want. On the plane, the wind is blowing 70 kilometers an hour, and it's southwest. And the plane velocity itself can be represented by this arrow here. That's what we're going to solve for. The resultant of those two vectors needs to be, let's represent it like that, 553 kilometers an hour. Okay, east 60 degrees south. So not to scale or anything, but just to kind of give you an idea. The vector addition of the velocities have to sum up to 553 kilometers an hour, east 60 degrees south. So the correct drawing or sketching of that diagram tells you your equation that you're going to use. You're going to add the velocities as a vector sum, and that sum has to equal 553 kilometers an hour. So I'm going to write that down in words. So the resultant velocity, okay, that's got to equal the velocity of the wind added to the plane velocity. Okay. Remember, it's the plane velocity that we're trying to solve for. Our resultant velocity we've already calculated. So just rearranging that a little bit, the plane velocity, I'll call this VP, has to equal the resultant velocity. I'll just call that VR, subtract the velocity from the wind. Okay. Similar to a question that we did earlier. Okay, so as always, we break up the resultant velocity to be its eastern component. That's going to be 553 cosine 60 degrees. And really quickly here, I'll calculate that. Comes out to be 276.5 kilometers an hour eastward. And then we have our resultant velocity in the north direction, 553 negative, because we're going south, cosine 60, sorry. Northern component is the sine, sine 60. And we get 479, negative 479. So our resultant velocity, what we want to end our plane to end up having, we have those components broken up. Now we need to break up the wind. Velocity of the wind in the east is going to be negative 70 cosine of 40. Again, it's negative because it is directed west. Negative 53.6 kilometers an hour. And then the velocity of the wind in the north, it's directed south, so it's going to be negative 70 sine 40 degrees. That comes out to be 45.0 kilometers an hour. Okay, so now we're ready to do our calculations to figure out what the plane velocity is in the east. Oh, that's going to be the velocity of the resultant in the east. Subtract the velocity of the wind in the east. Okay, just going back to our formula that we did up here in this step, right there. But we have to work with only the east's components right now. So that's going to be 276.5 subtract negative 53.6. Okay, so the formula says subtract, but the component comes out to be negative, so we do take that into consideration. It becomes a positive. We end up with 330 kilometers an hour. So the eastward component of our plane has to be 330 kilometers an hour. Now we do the same thing for the north. The plane in the north, so the resultant velocity of this plane that we want in the north minus the wind's component in the north. So we get negative 479 minus negative 45. So once again, we've got to add the opposite there. We get negative 434 kilometers an hour. So the northern component of this plane has to be going negative 434 kilometers an hour. In other words, it's got to be directed south. Make sense? All right. Result needs to be in the south. Put it all together. Velocity of the plane is going to be 330 squared added to negative 434 squared. Of course, everything's going to be positive and square rooted. And that comes out to 545 kilometers an hour. So our plane, if we see a speedometer on that plane, it's got to be going 545 kilometers an hour. Now the key for this is how we direct it considering the wind, and that is calculated through the inverse tangent of the northern component, the plane's velocity, the eastern component. Tan inverse of 434 over 330. And it comes out to be 53 degrees. So putting everything together, the velocity of our plane needs to be 545 kilometers an hour on a heading of east, because it's a positive value, 53 degrees south, because our component is negative. So if our plane's velocity is that, combined with the wind, we get a resultant velocity which will get us to where we want to go in the time allotted.